So we're going to start today's meeting of our Introduction Networks class with a discussion of SSH and how to set it up on a device. Now, we have talked about how you can telnet to a device. So telnet is the ability to get into the B2I lines on a device, and it's the ability to do what's called in-band management. Now, if you'll remember, when we talk about in-band management, we're talking about managing across the network itself to your devices. When we discuss out-of-band management, that means plugging into the back of the router's console and using a console connection. So SSH and telnet are both in-band management. So we're doing it across the network. The problem with telnet is it is completely clear text. So if you log into a router using telnet, you're giving away your password to anybody who can sniff that network or run a packet sniffer on that network. So we don't want to do that. That's obviously a no-no in the real world. So we must run what's called SSH or secure shell. Now, secure shell is really pretty simple to set up. And so what I'm going to do is I'm just going to go through the process here to set up secure shell. And I'm going to start by, I'm going to do a basic configuration on my router. So I'm going to go into my router here. And we're going to do what I would call just a basic config. And that would be, we must set a host name. Now, that is one of the most important things because the host name and the domain name that you set on the device is used as salt or seeds for the crypto keys that you generate in step 3. So if you don't have a host name, you cannot generate crypto keys. So we're going to do that first. Then we're going to go in here and we'll set enable secret. Well, actually, let me do this since I'm getting these messages here first. Let's do a line con 0, login, password of Cisco, login synchronous, so I won't get crazy stuff in here. I'm going to go ahead now and go back out and do an enable secret of class. I'm going to set a banner, MOTD, pound, stay out. And yes, that's not a very good banner, but I'm doing this for speed's sake, not necessarily for an excellent banner that could survive a legal challenge. All right, so now we need to set an IP domain name. So IP domain. Now here's where it gets a little funny. On some switches and some iOS versions, it's domain dash name. On iOS 15, it's domain name, and then you got to put in a domain name. I'm just going to use cisco.com.
I have a problem with that. I use domain dash name, and then they're racking my brain before trying to find out exactly what the problem is.
Well, here's what you can always do. If you do put in something that's IP domain, and I run into this again, it depends on the version of iOS. If you tried this, you'll notice here, look what happens. You see how it put the caret right here? That tells you where you need to stop typing. So that tells you to go IP domain ? And you'll see that there's nothing, there's no dash. So then you do a space ? And you'll see that, oh, now this is no dash. So you can actually use the error message that it gives you. So if I do this, if I do IP domain name and it tells me that's where the error is, you use your troubleshooting, you back up to that one point right there, do a ? And it says, okay, domain space ? And then name. Okay. Now, like I said, on the switch, I could jump over to the switch right here. And on the switch, you're going to notice that when I set the domain name, it's a dash. So on the switch, it uses the dash. On the router, it does not use the dash. That is completely dependent upon, you notice it will also take no dash on the switch, but it will not take it on the router. So you just have to really kind of play around with the iOS and see what version of the iOS is being used by the device to know what to put in. But now I have done a basic configuration. The only thing I haven't done here is let's go ahead and I have not configured my V2I line. So let's do line V2I 04 since this is a router, password of Cisco. Even though this will really not get used, I also forgot to do service password encryption, which I would consider to be a basic command, then a do write. So I'm going to write my configuration. So I did the first part, the first 2 steps here. Now I need to configure a crypto key, because with SSH, you share a public-private key pair. So we're going to end up sharing a public key that will be used to encrypt information going to this device. So we'll do a crypto. Oh, let me show you something real quickly, just in case you run into this in the real world. If you do a show version, you'll notice that this iOS that is running on this device is a universal K9 image. If you're ever trying to configure SSH or any kind of security feature and it's not working, if you do a show version, you will probably find that it is not a K9 image. The K9 means it is the cryptographic image, or it's the image that supports cryptography and security features. There are some countries in the world that K9 images cannot be shipped to, so Cisco actually makes a non-K9 version of their iOS. So be aware, if you're ever trying to do this and it simply will not work, you want to look and see if it's a K9 image. Okay. So, all right. So now we're going to do a crypto key generate RSA. It's going to ask me for a size. Typically we use 1024 to 4096. I will warn you, if you use a really high key, it may take a while for your device to actually generate the key. And I've actually locked up a device once while I was generating the key. I tried to generate too big a key. It was on a Cisco Pix. But now you'll see that we've got that key generated. In fact, if I do a do show run, you'll now see inside the running config, you should see a key here. I haven't saved it yet. Let me do a do write. And let me see if I can't show you the key. Most iOS versions will show you the key. Maybe this one does not. This particular version doesn't. So let's do a do show crypto key RSA. Crypto key, let's see if I do it. Question mark. Right there is my pub key. My pub key. Question mark. RSA. Okay, so there's my public key. There's the public key that we just generated right there. And you can see, here's why we've got to have both a domain name and a host name set, because this is what is used for the key name. The host name added to the domain name. Okay, so this is a general purpose key here. Now, the next thing we need to do is we need to create a local user that we're going to log into on this device. So let's do a username. I'm just going to do an admin with a password of Cisco. Okay, and that's fine. It's giving me a warning, but that's okay. Last but not least, we got to set up the device to support connections via SSH. Do a do show run right now. You will see that the VTY lines are set up to accept either SSH or Telnet, but we wanted to only accept SSH. And we also only want you to be able to log in using that local username in the local database. So, and by the way, if I scroll back up here, you can see the username that I added in here. Here's our user. So this is a user that's been added in step 4 to the local user database. In the real world, by the way, we would probably not use a local user database. We would have it go to a TACUS or a Radius server. Or an ICE server, an identity services engine server from Cisco, and we would actually log in with our domain accounts and our domain information, not a local user account. But since this is CCNA level, we don't really teach our students that at this point. Okay, so let's go into line VTY 04. We're going to tell it to log in local because we want it to log into that local user database, and we're going to say transport input SSH. So now it's accepting SSH. The other thing I've got to do now is I've got to actually go into the interface and put an IP address on it, which I forgot to do during the basic config. So let me go over here, because if I can't ping it, I'm not going to be able to get to it. Okay, gig 00001. So let's go in here. I forgot to do that. So let's go interface G001. IP add, and this is just a standard putting IP address on the interface of a router. And the one thing most people forget to do that I forget to do all the time is I forget to issue the no shutdown command. Now at this point, There's one other item we could do. We could do SSH or IP SSH version. You could
So
set the
Kelly,
version.
before you go further, why do you use the 12 when you do the IP address 192.168.12-1? Why do you use that one?
Honestly, that's just my favorite IP address range that I use for all my examples. I always pretty much, if you see any example that I do, I'm going to use 192.168.12.0/24 somewhere. And I don't know why. That's just what I use. It could be anything. It could be 10.0.0.1/24. It could be 15.0. I just always use 12.1. And you know, if you're around me long enough, you'll notice that, and you'll notice that I tend to use that one a lot. But that's the only reason. I mean, with the lab, honestly, the lab tells you to use. I don't even know what the lab tells you to use.
It's 0.1.
It's 1.1. Yeah.
Yes.
So I just use 12.1. I can change it to 1.1 if you want me to. I'll change it to 1.1. But I like to use that one. And the other thing I like to do too is, I'll show you this. I can hit the up arrow. Watch this. I can do Control A and put no, and that removes the IP address. Hit the up arrow a couple more times, and I can come back here. And so what the lab was asking for was 1.1. Okay. So we got 1.1 and the PC is 1.3. So I'll know to put that on there. Okay. So let's now see if, let's change our SSH version. And we don't have to, but if you wanted to use a different version, you could do IP SSH version 2, which is a more secure version than 199. Okay. So real world, yes, we set it to version 2. In the lab, I don't think they have you do that. They may have you do it on 1 or 2 of the labs, but not all of them. So, and then now let's exit out of here and do a copy run start. Make sure we've got it saved. And just to make sure we've got everything right, I am going to do a show IP interface brief to ensure my interfaces are up. So let's show IP interface brief. So 192.168.1.1 is up. So we are good there. So now let's go back over to our PC. Let's go ahead and put our IP address on here. So I believe in the lab it wanted 192.168.1.3. And then the default gateway is the closest router port on the same network as you. So 1.1. Make sure you click OK twice. If you don't, it will not apply. So you got to make sure that you click it twice. And then we should be able to go in here now. Let's do this. Let's do actual size, IP config. And we see 192.168.1.3. A lot of times I'll ping it before I try to SSH to it just to see if I can ping it. Now, just because you can ping it doesn't mean you can SSH, and vice versa. I can also set up an access list that blocks ping but allows SSH. So at this point, though, I do know I can get to the router with a ping. So I'm going to go to PuTTY, click yes, and I'm going to say I want to connect with SSH, and I'm going to go to the IP address of the router. Now watch what happens when I click open. It's going to say, the server's host key is not cached in your registry. Do you want to cache this key? In other words, it's saying, do you want to cache the public key that R1 is sending as part of this communication? The answer is yes. Then you want to put in that username we created, which is admin, with a password of class. And if I put in the right password, oh, no, password Cisco, not class.
Cisco.
Yeah, Cisco. There we go. Now look, I'm now in the router. And I still have to use but I am fully in the router now. And I'm in there via SSH. Show SSH, there it is. You can see that I am connected with version 2.0. And you can see the encryption algorithm being used is AES 256. HMAC is SHA 256. You can see the username that is currently logged in is admin. So this shows me the SSH session that I am connected to via this connection. So again, the most important things are, oops, wrong thing, that's for a little bit later. Basic configuration of the device, configure IP domain on it, generate the crypto key, create local user account, set the V2I lines to authenticate, and then configure the V2I lines to accept inbound SSH. So let's do this. Let's go real quickly over here and let's do it on the switch, just to show you the config T, hostname S1, IP domain, name, cisco.com, int VLAN1, IP add. What was the IP address they were asking for on this one? One dot what?
It's 1.11.
11. Okay. Oops. And then we'll do IP default dash gateway, even though we're not going to need it here. We still want to set it because it's just to make sure we don't. Okay. Int VLAN1, it should be no, it should be on anyway, but let's go ahead and do that. It would enable secret class. We'll do line on 0, line synchronous, Cisco login, line V2I 015. Since I know I'm going to be using SSH, I'm just going to go ahead and do IP or transport input SSH, and I'm going to do login local. So I'm not even going to bother to put the other password and everything in there. Drop exit, service, password encryption. Okay. Then we're going to do, we need to generate our crypto key. So we've got our domain name, we've got our host name. Okay, so we got got the basic configuration. We didn't put a banner message of the day. We're going to let that go. We've done the IP domain. We have not generated our crypto key, and we haven't set our local user database. So let's generate our crypto key. Crypto key generate RSA. Modulus 1024. Now we'll set our local username. Username admin. Password of Cisco. Okay, notice that by default, SSH version 199 is enabled. Okay. So now we've done our user and local database. We've already set the V2I line to authenticate using the local database. We've set it to accept SSH. So now we're going to type exit. We're going to write this. We should now be able to go to PCA and open up a new SSH session. And we should be able to go to 192.168.1.11. And you see there, we download the key, log in as admin, Cisco, and now we're logged into the switch. Okay. So what we're doing with SSH then is very simply creating a secure in-band management with a device. Jacob, does that help?
Yes, when I get into the SSH, it doesn't give me the login. It just give me the black, and then I have the, don't know exactly what I did. But after some time, it tell me that the time is out.
You probably, if it is not giving you, if it's not giving you your the login, there's one of two things you've forgotten to do. One is you either did not, well, more than likely, you did not set the following. You've got to set login local on the V2I lines.
Yes, I did.
Okay. And you put transport input SSH on the V2I
yes,
line.
I did that one too.
Okay. But it's not giving you a log. Are you? Okay. Hold on one second. Let me do something. Let me do something here. Oops. Yep. Yeah, I know. It popped me out of there. Give me 1 second and I can. This is one of the beauties of NetLabs, and it's one of the reasons why I love this system so much, is because I can actually, let's see. I can look at your final config. Okay. All right. This should not have caused an issue, but you notice how you put telnet SSH? That should not have caused an issue. Still should have been able to telnet it or to SSH to the device. You do have your username. I can't see whether or not there was a crypto key generated, but actually I can, because what's this? Actually, session log. I can actually look in here and see. Okay, so you got all your basic config there. There's your domain name. Okay, so that gave you that error message. Okay, so it took it right there. Oh no, it did not. Has not taken the domain name. Okay, because see, it never took that, but there it took the key. Okay, so you did get the key generated. So that should have worked. You should have been able to SSH to it. Yeah, you should have been able to.
What I observe is that after I log into it, and then because I try it through the Terra dev terms, and I try it through the Cisco configure, that's another question for you. But when I try it into, I think through the Terra or through the Cisco, it has me for the IP, then the username, and then the password.
Yeah.
And when I did that one, which is one of the things that the sources to do back there.
The username would have been admin.
I have to go back and look at your recording and see exactly where I made the mistake.
Yeah, the username should have been. It looks to me like it should have worked because you've got your domain name. So you got your domain name here, csna.com. You got your host name set. You generated your crypto keys, which I could see up here further where you generated crypto keys. So it should have worked. That should have worked. The only thing I could see is maybe when you did, make sure when you're using the PCs to log in, make sure when you're opening PuTTY that you are selecting, I mean, it's selected SSH by default, but just put in the IP address of the device that you're trying to go to. And it should definitely have, it definitely should have worked. You see here it is, letting me in with admin again. So, and the only difference I have, the only difference between my setup and your setup is that I went in on here. You'll notice that the only difference is, and it won't make a difference at all because the way this is set up is transport input SSH. If you put telnet SSH, it will accept either one. You can also put SSH telnet and it will accept either one. So should have worked. Well, what you had should have worked. So I don't know exactly what you were seeing in terms of an error there, but go back and try it again and let's see if that'll help. Okay.
Okay. Another question along that way, because the Terra terms that if you go to the PC in the lab, when you click on it, they have the Terra terms that they say we can use them to log into the SSH. And I tried that one to give me the same thing. So
you tried using the SSHing from the command line.
Terra term,
yeah.
And then they have the Cisco configuration too. Okay, you see the Terra term.
Yeah, and you should be able to do it with it from here too, as long as you do an SSH connection. So yeah, here it should just be 192.168.1.1, and then you there it is. There's the key. So you're adding the key, username, admin, Cisco, and there it is.
Well, my story is that you run out of time after some time, so I don't know. I have to go back and look at it.
Go back and look at it because it looks to me like it was right. So I don't know. I don't know exactly what the issue was, but you can use either TerraTerm or PuTTY. I like to use PuTTY personally.
How about the Cisco configuration
Yeah.
on the left? That one.
Yeah.
Mhm.
No, this one is not designed for. This is designed for. It's really only used in a security class that we have, so that's not designed to do it. That's you're going to be either using PuTTY or TerraTerm, or you could possibly. There is a way to do it if it's loaded, and I don't think it's loaded on this from the command line. All right. Any other questions on that?
Okay.
All right. Well, let's pick back up. We stopped last week at 14.3.4, looking at applications using UDP. And remember, we talked about how at the transport layer, we had two primary protocols that we use. TCP, which is guaranteed reliable delivery, and UDP, which is unreliable but fast delivery. We also have what are called port numbers or ports, so that we can keep up with multiple communications. Whenever you connect to a different, like right now, I'm connected to Netacad, looking at our course inside of Netacad. I'm also connected to a completely different site, looking at the content of our curriculum, and I'm connected to NetLab. So I'm connected to all three. Well, in order to keep up with these, my computer is using multiple separate communication channels. And it's doing that through a combination of source ports and destination ports. So I've got a source port connecting from my machine to the TCP connection to lms.netacad.com. I've got a different connection with a different source port going to the destination of contenthub.netacad.com, and yet another one going to netlabs.stanley.edu. So we can use these in order to keep up with different separate communications. These are called socket pairs. In other words, if it's an IP address plus a source port or an IP address and a destination port, it's called a socket. Now, when we initiate communication from a client to a server, the clients typically pull a random source port above 1024. All right, that's the typical thing that happens. It's a random port. When we connect to services on a server, we're typically going to a well-known defined port. So for instance, if we're connecting to a web server, it's port 80 or port 443 if it's secure. If we're connecting to an FTP server, it's port TCP port 21. So these sockets are an IP address and a port number related together. Here are some of the well-known ports are 0 to 1023. We'll look at some of those here in just a minute down here in our well-known port number chart. Registered ports can be those ports above 1024 to 49.151. This means there are some ports in here that are registered, plus some that can be used for random source ports. And then, of course, we also have 49.152 to 65.535, which can be used or what called ephemeral ports or those source ports. Well-known port numbers. I would at least memorize a good part of this chart. TCP port 20 and 21, that's FTP, data and control. TCP 22 is SSH. This is going to become important when you get into CCNA 3, when we start writing access control lists, because they're going to ask you to control traffic to certain ports. You're going to need to know what protocol and what port is used for that particular type of traffic. Telnet is TCP 23. SMTP is TCP 25. DNS, again, remember, this is our weird one. This is the one that uses both UDP and TCP. It uses UDP 53 for a client requesting DNS information from a server, and it uses TCP 53 when servers talk DNS information between one another. These two you may not really need to remember, but just remember that DHCP does use UDP 67, 68. You don't have to, those don't show up quite as much as some of the other ones. TFTP is UDP 69. HTTP, you should know that that is TCP port 80. That's an important one. You should also know that HTTPS is TCP 443. These other ones here, POP 110, 143, 161. If you work with networks enough, you'll need to know these because you will have to deal with these in some form or fashion with access control list. One of the things you can do, you can always do a net stat command, which if you're in here on a machine, you do a net stat. It will actually show you your connections and what you're connected to. Okay, this particular PC here, you'll notice that we have an SSH connection right here. So this is showing me that my ephemeral port for the connection, and by the way, I've got two connections because I got one through TerraTerm and one through PuTTY. So I've got one connection using the ephemeral port of 1849 going to SSH, which would be TCP port 22. They just go ahead and call it SSH so that you don't have to see :22. And then this ephemeral port of 1850 is used with my other application. So let's go ahead and close TerraTerm. Let's see what happens to these ports. So notice right now it's established, and we'll talk about what established means here in a second. But you should see it closed or gone here in just a second. One of those two, it'd probably the 1850 will be disappeared. Yep. So 1849 is still there. 1850 is under a time wait, which means it has not yet removed it from the connections, but it is getting ready to do so. Okay, and we'll talk about what that means here in just a minute. But this netstat shows you all of the connections that are on your system. This is a good way to check to see if your machine's been compromised. Although I will tell you this, good hackers will make sure that their information doesn't show up in this netstat. They'll rewrite netstat so that it doesn't display their bots and things that are inside of your machines. Okay, but that's what the netstat is showing here. Now, TCP, because it is reliable, guaranteed delivery, it has to have some processes associated with it. The first one is what is called the three-way handshake. And with TCP, before you ever send anything between two devices, the very first thing that happens is client A sends what's called a SYN, and it says, hey, are you there? You'll notice it's got a sequence number of 100, and it is a SYN. The SYN bit is set on TCP. B will receive that. It will send its sequence number and acknowledge A's sequence number by incrementing it by 1, and will send what's called a SYNACK. And then finally, A will ACK the sequence number from B, and this will give you a fully established session. Without this three-way handshake, there's no established session. The way I teach this to my students is this. You're going to a friend's house. You call them on the phone. Are you at home? B responds, yes, I'm at home. I'm going to be here for the next couple hours. A then says, okay, great, I'm coming over. That's the three-way handshake. This way, I ensure that I'm able to connect to B before we ever try to send anything between the two devices. There's also session termination. There's two different ways you can actually have a session termination. One of them is with the FIN bit. So you got no more data to send. So you send the FIN, the receiving client says, okay, receives it, sends an acknowledgement, and then sends its own FIN, and then the session is dropped. Okay. I make a joke about this being, you know, when you break up with somebody and you actually go out with them and tell them you're going to break up. Okay. And then the other way to do it is with a reset. And with a reset, you just quit calling the person or talking to them. That would be, you'd be ghosting somebody. You wouldn't talk to them anymore. And that would be the reset way to drop a session. It's preferred with TCP that you use the FIN bit. Okay, because that ensures that that session is closed like it is right here. And you'll see eventually that is going away. In fact, I actually lost my PuTTY session. See how it dropped? So this PuTTY session dropped. You'll notice now that I have no connection between, I have no connection here in my netstat. So I can see that PuTTY has dropped. So let's do this. Let's reestablish it so you can see that going back into the netstat. All right. So now if I do up arrow, you should see. Now it should be a different port than 1849. It's probably going to be something different. Yep, 1868. But you can see that from 1.3 to 1.1, this socket this source socket has connected via TCP to this destination socket, and we have an established session. So we have a three-way handshake's been established, and we have full communication between this host and the router. All right. So again, inside of TCP, there's these 6 control bits that we have. You'll notice again, we talked about how much this header, how complicated this header is as a source destination port. Source port will be an ephemeral port on the client going to a destination, and then it will be the destination port will be whatever service you're connecting to. And then those ports are reversed when the information comes back. But in the control bits, there's urge, act, push, reset, send, and fin. I would know those 6, and those 6 are important for your students to know. You're not going to have to do a whole lot with them in terms of right now, but as you move on in the networking world, it's just good to know these because they're also used a great deal in security. So we can use what's called different types of SYN floods, and we can use different types of scans to try to get devices to tell us what ports are open on them. So that's how these 6 flags get used, or 6 control bits are used in the world of computer security.
Professor Kelly,
Yes.
if we use the Wireshark, we get some kind of like a port information. Is that another way of getting the feedback?
Yes, definitely. You could open up Wireshark here, and inside of Wireshark, once it's running, so for instance, let's actually drop this. Let's close both of these PuTTY sessions, okay? And let's go with that right there, the Pro 100. So we're going to start a capture. So we're capturing. So we're going to open up right here. I'm going to go to 1.2.168.1.1. Oops, 1.1. Log in as admin. Okay, so we're in. I can actually go over now here, and I could stop this and apply a filter. It should be able to do SSH. And you can see here's all the SSH communication. So this is actually showing you the key exchange. So here's the actual key and keys that are being exchanged here. If we dig in here, you can even see the beauty of this is it even shows you the source and destination MAC addresses. It shows you the IP addresses that are in here. And all this is important because it's important because I was going to show you this very thing right here, and how when we communicate between 2 devices, one of the things we do is we take that request, and in this case, our request has been an SSH connection. So in other words, we've requested to connect via SSH from 1.1. So this, if we dig all the way down here, you'll look, this is an SSH server to client. Okay, so the server is talking to the client. Should actually be the client talking to the server, but we've got that going in there. But we'll notice this rides on TCP. And you'll notice that the source port, this is from client to server. Oh, here it is. It just for some reason grabbed it backwards. So here's client to server. You'll notice that the client has a source port of 1870. The destination port is 22. The source IP address is 1.3. The destination is 1.1. This, by the way, this one up here was the closing of that previous connection. But here's that connection here. We go on up, and you'll notice that here is our source and destination MAC addresses. I wanted to show you this is what happens anytime if we connect from a client to a server. We could take the request, put it as data, put the application header on it. Then down at the transport layer, we're going to have a source port and really a source port and a source protocol, and a destination port and destination protocol. Typically, it's one protocol, though, because it's going to ride on TCP or UDP. That then becomes data, and then at layer 3, or the internet layer, you're going to have the source IP, destination IP. And then at layer 2, you've got the destination MAC and the source MAC. And that is exactly what Wireshark is showing us here. Here's the entire process. Here is a, excuse me, a client requesting an SSH connection to a server. You'll see that this is a TCP connection from port 1870 to port 22. In fact, watch this to even be more interesting. We can now go over here and do a net stat, and we should see 1870 as the port number. Yep, see port 1870. So right here it is. There's that port connecting to the host. Okay, 1.1 will be SSH, which is port 22. And then this goes on up and shows us here are the IP addresses. Okay, source of port, source is 113, destination is 111. And then we're going up, and here is source destination MAC address. So this is all the parts of everything we've discussed in this entire course. This is everything we've discussed all together to allow communication between PCA and the router via SSH. And that's one of the key parts and key takeaways of this entire chapter, is that we're seeing how that communication is taking place. Now, as these devices are communicating, here we have again, everything being broken into segments. So if I was communicating a large amount of data between these two devices, it wouldn't try to send it as one big block. It would send it as multiple different segments. Well, because those segments may take different paths and may arrive in different at different times, there's got to be a way of putting them back together. And that is your sequence number. So when you go down through here and look at TCP, you'll see the raw sequence number here for this particular packet is this very large number. Now you have to be careful with Wireshark, because by default it will use what are called relative sequence numbers instead of giving you the raw sequence number. But you can change it to show both. In this case, it's been changed to show both in the options. But that's how we put these pieces back together. Each one of these different packets has a different sequence number. Okay, so this is 806, and then this one coming from 1.3 is 34, and let's see if this is 885, so it's using relative, that's 20, relative packet number 20. So basically it's using a relative packet number here. But those numbers are how the devices put that information back together in the correct sequence. That's the sequence numbering and sequencing that is part of TCP. TCP also has reliability. It has the ability to acknowledge the receipt of X number of segments. So by default, what happens is what's called a sliding window. In other words, A and B will decide that we're first going to send 10 segments and acknowledge those. And then if that works okay, then we'll try to send 15 segments, and then we'll try to do 20 segments, and so on and so forth. So the window can get bigger or smaller. And so when the window gets too big and things start getting dropped, they will actually slow down the process. In other words, they'll decrease the number of segments that need to be sent or sent before you had to have an acknowledgement. But you also notice what it acts. It acts the numbers that it missed. So when it gets here and says ACK 11, it starts sending 11. But if you get this and it says it acts 3 and 5 through 10, it's selectively acknowledging these items, and it says, okay, I've got 3 and 5 through 10, so I need these other ones. I don't have 4, 11, and 12. And it will go on through and acknowledge those. TCP is an amazing protocol. The other thing about TCP that's a little bit weird is what's called this window size. When Windows 95 first came out, Microsoft made the initial window size for TCP too small, and it was greatly affecting the speed at which Windows would connect over the internet. So you could speed up your internet connection greatly by increasing the window size inside of the registry. It's not true anymore. Now the window size is big, but you'll see here what happens is during that three-way handshake, we decide that our window size is 10,000 and a maximum segment size is 1460. So that means the biggest the segment itself can be. It'll send up to the number of segments, and then the window may be, it'll be acknowledged, and then the window can actually grow. So the window size, this is called windowing, or, oh golly, totally lost it. Not select the window size, but windowing and changing of the window size. sliding window. There we go, sliding window. So today's sliding windows protocol. So after we acknowledge 2 segments, it'll actually continue to grow the window until you start dropping segments, then it will start over. Now, maximum segment size is important because it has to match the medium you're on. So for Ethernet, we know it's 1500 bytes is the biggest segment size. They do typically, a lot of times it's actually 1460 because they leave overhead for things like VPN connections or other items that can take place. And then congestion avoidance, again, one of the things that can happen with TCP is with flow control, the host can actually say, whoa, 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 slow down, I'm getting too much information. And that is available for TCP. And then I love this little part about UDP. UDP says, okay, guess what? It gets sent, we hope it gets there. That's literally what UDP does. UDP does not have any way to retransmit. UDP does not have any windowing. UDP does not have any kind of control. It sends it, hopes it gets there. If there's any type of control taking place, it has to take place at the application layer because that's where these protocols have their built-in control features. UDP cannot do any of those windowing, control, 3-way handshake, none of that. UDP is all about speed. Okay, questions? Again, this is what we have with TCP. We've got this being built, and it would also be for UDP. You could definitely just do UDP, but you wouldn't have all the windowing and everything else that we have. And again, if you can use Wireshark in your environment, especially like I said, even with NetLabs, see, I've got it in here in NetLabs. This can show you all kind of great things. I can show, let's try TCP and see if I can't just see.
UDP too.
That one. Let me clear this, clear all. All the way up here, PVST plus. Here it is. Here's the send, SYNAC, and ACK. Right here's the initial 3-way handshake in order to do the communication for the SSH communication. Right here they are. Here we see 1.3 to 1.1 sending a send. Okay. By the way, that's just a timeout that occurs if you stay connected for too long in SSH. So here we see the send being sent from 1.3 to 1.1. Here's the SYNAC being returned from 1.1 to 1.3. And then here's the ACK, which establishes the session with 1.3 and 1.1. So here's our send, SYNAC, and ACK before we start our SSH connectivity. So this kind of thing that you can show your students is extremely important because now as we get into this 14th module, we're taking all these pieces of everything we've learned from protocols, numbering systems, switching, all these different layers. Now we're putting it all together so that we can see how communications actually take place in a modern network. Any questions?
But not in details like the way that we learned in the beginning. Because because you have been doing it all the time, you omit some steps and it still work for you. It is going to take us some time because when I run into either the configure the switch or the router, I go back to the beginning of the step that we go through, and sometimes like I say with the way that you're doing it, you omit some steps.
Yes,
it still work for you.
Right.
But I'm not yet there.
Well, and let's be honest. I've done this for 23 years now. So, you know, I've worked on Cisco routers and switches for 23 years. So if I do actually, if I don't describe a step or something, I do apologize. I try my best to make sure I'm showing everything. But again, when you get a couple more years on your belt, a little more time, by the time you get to the 3rd class, you will be comfortable with this. It's just do the labs. More you do the labs, the packet tracers, the better you will get at it. It really is just, it is a constant getting more hands-on, more experience with it. And your students will be the same way. Your students are going to be trying their best to get those hands-on skills so that they're able to do it. Yeah. Any other questions?
So some of those things that I used to go and look at it in the beginning, like what you said, like configure the switches or the devices. I do not have a problem with that one. I remember some of them, unless when I make a mistake, then I go back.
Right. And that's actually a good way to do it. If you try to do it without notes first, and then if you need to go look at notes, do that. So, okay, I'm gonna stop the recording real quick.